Today we're going to talk about 23C fast ingest enhancements. This is for the mem-optimized row store. My name is Andy Rivenis. I'm a product manager for database and memory, but I also handle the mem-optimized row store features. And so today we're going to go over kind of what the mem-optimized row store, what fast ingest is, and then the enhancements that we've made in Oracle Database 23C, and I'll show you some demos on Oracle Database 23C free. So the mem-optimized row store is actually made up of two features: fast lookup, which enables you to get very fast retrieval for high frequency queries. It basically does everything in memory. That was introduced in 18C. And then fast ingest, which we introduced in 19C, and that enables very high speed insert performance, kind of bypasses the normal Oracle transaction processing and inserts directly into memory, and we later drain that out to the disk. But what it does is enables you to have a very high volume of inserts, not so much data volume, but transaction volume, and ideal for things like Internet of Things applications. One other thing, the mem-optimized row stores is not part of database and memory. This is included as part of Oracle Database Enterprise Edition. So let's talk a little bit about fast ingest. So as I mentioned, the idea is that you can insert directly into memory. We have a special mem-optimized write area in the large pool, and then behind the scenes, we'll drain that data out to disk. And so there is a period of time where it's just in memory. And so that data is volatile when it's in the large pool in the memory buffers. If the instance were to go down, that data would be lost. So this isn't for data that needs to be strictly ACID compliant, but it allows you to insert and basically reduce insert latency and then get large numbers of inserts for sensor data streaming applications where data really makes more is more important in the aggregate than it is in the individual transaction level. Allows us to get much higher throughput than we can with a traditional insert architecture of Oracle Database, or even insert appends, direct path inserts. So this can be a very useful feature, but it isn't necessarily for everything. The other slight issue with this is that obviously you can only allocate so much memory. And so once the memory is full, then we have to wait to add or insert more data until the background drainers have drained the process. So you do have to keep in mind the memory constraints as well. Under the covers, we're just allocating space on a large pool. We have then background processes that drain the inserts that have been made. One of the interesting things is there's no concept of a commit with fast ingest. So the data is committed essentially once it's written out to disk. And so there, as far as the application is concerned, is just a fire and forget type of insert processing. Very typically, the architecture would be an application server getting lots of streams of data from different type sensors, and then batching that up into bigger writes into the database in the fast ingest pool, and being able to then write many transactions per second, as opposed to being limited by the normal Oracle database transaction architecture. And I mentioned database persistence. So what winds up happening is the data is just written into the large pool. No, you don't issue a commit. You don't get any errors back as far as violating any constraints. All index operations and constraint checking is done once the data is written out to disk. So if any errors occur at that point, those rows just aren't written to the database. Remember, this is all based on speed. So again, it's data in the aggregate, not necessarily at the individual, if you will, row level. You can't read the data when you've written it to the large pool until it's been written to disk. So if you do a select immediately after writing or doing an insert using the mem-optimized write hint, then querying it back immediately, you may not get any data back. It won't be until that data is written to disk, and we'll show you that in the demos. And then again, if you've exhausted all of the space in the large pool, then you'll have to wait until that space is freed up. So that's just kind of the architecture of the way it works. There are some write verification APIs, and you can use these from an application standpoint to determine whether rows have been written to the large pool and whether they've made it out to disk or not. So we have two different you have a write high watermark and an apply high watermark. And so by checking these sequences, there's a API call through PL/SQL, DBMS mem optimize to then identify sequences, and you can track whether all of the data has made it in or whether you might need to retry and resend data if for some reason something happened. Maybe the instance went down, came back up, and you need to retry the data in order to get it into the system. You don't have to do that, of course, because again, if you take the advice of treating the data as an aggregate, then it may not be as important to check or to ensure that all of the rows have been written to the large pool and then thereby to the database. Now let's talk about new features with Fast Ingest in 23C. So we've added encryption support at the tablespace column level and with secure files. We've added compression support. We've added LOB support, as you can see, encryption support with secure files, but also in general LOB support. The ability to have interval partitioning, hash partitions, and subpartition support. We've also, we allow an explicit allocation of the mem optimized write area in the large pool. So there's a new parameter, mem optimized write area size. And then we also allow you to set a session level parameter, mem optimized writes, which you can use to avoid having to include the mem optimized write hint. So it makes it easier to use, and we've broadened the support for different features within Oracle Database for Fast Ingest. So I've got some features or some demos I want to go through. All of these demos are created on Oracle Database 23C free, the developer release. I downloaded the VirtualBox version and set that up. And so I'm going to run all of these demos and in that kind of environment. And so this is something that you can try today. You can download off of oracle.com the Database 23C free version, and you can get it in VirtualBox and various other forms and give it a try yourself. I've included the demo script on our GitHub environment, so I'll put that link and make that link available. So for setup, what I've done is I've already logged in and I'm going to run a script. And so this will just be a script that will run through all of the different demonstrations of the features that I wanted to show. It's easier than having me type it in. And so let's go ahead and get started. So initially what we're going to do is I'm showing you that there are two parameters, the large pool parameter, so large pool size, which is by default 0. And then there's the mem optimized write area size. Since we're in 23C free, we have smaller memory footprint. So we're going to set both of these. And I'm going to set the large pool size to 512 meg. And I'm going to set the mem optimized write area to 300 megs. And then we're going to go ahead and shut down and restart the database. This takes just a second. And we're closed, and we'll go ahead and start it back up. The database is now open. And so what we see now is we have a large pool size of 512 meg. And notice that we have the mem optimized write area size is set to 300 meg. And the default mem optimized writes is set to hint. So that I'll show you how we can change that. But so that's the default, which is the previous behavior, which means all of your inserts have to have the mem optimized write hint in them to take advantage of Fast Ingest. And then we're going to go ahead and create a memopt user. We set the default table space to memopt data. I created the memopt data table space as well. and then grant some privileges to it. So that's what we'll use, the user will use. And again, this is all in the script, so you can go ahead and just cut and paste or just run it in your environment if you wish. All right, the next thing we're going to take a look at is just a standard fast ingest insert. So now that we've created a table space, we've created the user, granted the privileges to the user, we're going to connect, as you can see, memopt and free PDB1, and we're going to go ahead and query the memoptimize. First, we'll create a table, test fast ingest, very simple, just 2 columns. Notice segment creation immediate. So we have to actually create the segment in order to then specify memoptimize for write. Then we're going to query the $V memoptimize write area, and we see that we don't have any memory allocated. So that's one of the things I mentioned that earlier, that it's the first insert using memoptimize write that will allocate the area within the memoptimize write area. Notice we do an insert, we're using the memoptimize write hint. Notice that I then query those rows. So what I've done here, we go back a little bit. So we first query. So we've got an insert. We're going to insert the first row, and then we immediately query it. Notice we don't see any rows in the table yet. And then I go ahead and insert 3 more rows, and we still don't see anything returned from that. And then what we do is we go ahead and run the APIs to get the high water mark for the write and apply sequence. So this is just so that we could verify that we've written data out. So this is what it looks like prior to having been written into the onto disk. And then we're going to go ahead and flush. So there's a DBMS memoptimize write end. Normally you wouldn't need to do this, but since we don't want to wait for the background processes, it could take anywhere from a couple of seconds for them to wake up and write the data out. So we're just going to go ahead and tell it to go ahead and write the data. We'll sleep for 10 seconds. Now we can verify that the 4 columns have been inserted into the table and they've been written out to the table. Notice now we have space allocated in the $V memoptimize write area. And then notice that we have session level statistics, and that shows 4 rows having been written, the memopt W for write. The fast lookup would be memopt R. So it tells us that we've written our 4 rows out to the, statistically, we've used memoptimize writes for those rows. And notice now that the get write high watermark sequence is still 76, but the apply high watermark has moved up to 56. So we have 76 and 50, and now 76 and 56. So that tells us we've written rows to disk. So that's fast ingest insert. So now let's look at the session level parameter for the memoptimize write. So this allows you to avoid having to put the hint into your insert statement. So let's go ahead and take a look at that. I'm going to go ahead and just run this across. So notice I've done an alter session, set memoptimize writes equals on, and then insert a 5th row into the table. And the same as we did before, I'm going to just say DBMS memoptimize write end. We'll wait for that the drainers to drain that data. And then notice now the 5th row shows up, and we see that we've written total of our session level statistics. Now we have 5 rows written. You can set it at the session level, and then you can avoid having to add the memoptimize write hint to your insert statements. Now let's show lob support. So what we're going to do here is we're going to go ahead and create a new table. Whoops, a new table. Notice we have a CLOB, and I'm using a secure file to support the test column CLOB that I've set. And notice the memoptimize for write label on the end of the create table statement. So now what we've done is we've inserted in 2 rows into the test SFI, or the secure file, if you will, into the table with secure file, or the clob of test, and initial value of 1 and 2. And then we select those rows. And again, we don't get any values because they haven't been written from the large pool area onto disk. So we issue our mem_optimize write end and sleep for 10 seconds to let that data get written out. And now when we query that data, we see that both rows have been written to disk. We now support lobs for fast ingest. And then let's take a look at partition support. So what we'll do is we'll create a partitioned table. Notice I've created a partition table by year. And then I've enabled one of the partitions, the 1998 partition, with mem_optimize for write. So not all of the partitions have to be enabled for mem_optimize for write. You could do it at the table level, or you can do it at the individual partition or subpartition level. Let's go ahead and continue on. And now notice that I've written 2 rows into the 1998 partition. Notice the date, the 1998 date, test, both test. And then I've selected them again in no rows. So we're going to go ahead and do mem_optimize write end and sleep. And remember that normally you wouldn't have to do that, but for our demonstration, this makes it simpler to ensure that we've actually got that data written to disk. And then we go ahead and select, and we see both rows. And then if you want an easy way to verify that they went to the right partition, was I have in the second query, I put the partition on the select statement. So we're actually querying just partition 1998. And again, we see both rows there. So our last demonstration is going to be encryption support. Now this is a little more involved because we have to set up encryption in the database first. So we'll first do that, and then I will create a new table space that's encrypted, and then we'll create a table that in that table space, and we'll go ahead and insert our rows into that encrypted table that resides in the encrypted table space. So let's try this out. So notice the first thing we've done is I've created a wallet. Actually what I've done is I've set the wallet root in the initialization parameter, and I'm going to shut down the database and restart it so that we can set the next parameter. So the wallet root has to be set first. So this takes a little bit of time. We can fast forward here. And then we start it back up again. And then notice that I've set the TDE configuration parameter for a key store configuration equals file. This is all documented, but you have now the scripts, you can do this. I then created the wallet directory. And since this is the free environment, it's opt-to-Oracle admin free. And then I created a wallet directory, which is the one I specified in the wallet root parameter above. Now that we've created the directory, we can now create a key store. Notice the administer key management, create key store. And we can verify that by doing an ls on the wallet directory. And notice there's a TDE, that's actually a directory that gets created. So we created the key store, and then we've opened the key store. We do a backup of it. And then now we can query that with $V encryption keys and $V encryption wallet. And we see that we have our key store, and it's open and available. So we'll continue on. Now we're going to go ahead and create our table space. And notice here that we have encryption using AES 256. Default storage is encrypt. And then we're going to switch over or actually allow quota for our memopt user. Then we're going to go ahead and switch over to our memopt user, create a table in the encrypted table space. Notice I have table space encrypted TS. And then we're going to go ahead and insert 2 rows into our test encrypt fast ingest table. We select those rows. They don't show up, so we know we've gone into the large pool area, the memo optimized write area. We say our write end, and then we sleep. Make sure those rows can be written out. So then we see that we've got 2 rows. Our 2 rows now show up on disk. I've just done a count star. And then we see that memory has been allocated. You'll notice that the U space will go to 0 if you're doing a single user system once all the rows have been drained and we don't have any new rows coming in. In an active system, you'd expect to see used space stay non-zero. But what winds up happening is once you've drained all of the data, then that goes to a 0. And then if we look at our rows written, we know that we've written those rows there. So we've also shown that we can support encryption as well. Where can you get more information? So I have several blog posts. You can check out those brand new blog posts on 23C enhancements that reviews some of the information I've provided today. There is a tech brief out, best practices for high volume IoT workloads, that positions how fast ingest might fit in handling high volume IoT workloads. And then, of course, you can go look at the 23C free documentation about fast ingest if you have any other questions. Hopefully you enjoyed this. Thank you.